So we're first going to go over the things to know and the different problems or types that you might have with this that you'll see coming up. First, the basic thing for completing a square is our purpose to do this is to get this kind of thing, x plus or minus something squared. That if you then multiply it out, let's say it would be x minus 3 squared. You would do x minus 3 times x minus 3, and then when you multiply that, x times x is x squared, x times negative 3x, negative 3 times x, and negative 3 times negative 3 is positive 9. So you get x squared minus 6x plus 9. So here you have x squared minus 6x like this. So what we need to do, if we want to turn this into that, you need a positive 9. So what we have to do is add 9 to it. How do you know it's 9? If it's not this, if you don't already know this, how do you know to add a 9? There's a little formula that tells you, okay? And remember, these are written up as ax squared plus bx plus c. So the coefficient in front of the x squared is a 1. The coefficient in front of the x is a negative 6. The b is a negative 6. And the c is going to be 9, but you need to know how to get that. Here's how you get it. To figure out what the c is equal to whatever the b is, divided by 2, and then squared. That little formula will give you the number that you need to put here in order to complete the square. So negative 6 over 2 would be negative 3, so I'm going to do that here. Negative 6 over 2 squared is equal to negative 3, or whoops, just negative 3. Negative 6 over 2 is negative 3, and if you square negative 3, you get a 9. That's how you get the 9. Once you get the 9, you now have this, and you recognize that the purpose for doing it was to get to here, so you take half of this number. Remember, you divided by 2 here, and you got a negative 3. That's the number that goes in the parentheses. Let me show you another one. Let's do x squared minus 14x. So if I want the correct number here, I need to take the negative 14 and divide it by 2 and square it. Just like I did here to get the 9, I'm going to do it again, but here I used negative 6 because it was the coefficient of the x. Now I use a negative 14. Negative 14 over 2 is negative 7. When I square that, I get 49. So 49 is what I have to write in here, plus 49. And because I did this method, that's the perfect number that allows me to make this x minus 7 squared. That when I had divided by 2, I got the negative 7. That negative 7 is what goes with it. It's half of the b and the same sign. You're going to do this now. I think on the test I counted once. It's like 7 different times you have to do it for me on this month's test. Okay? And then there's times when you don't have to do it, but can choose to do it for certain methods. So you could do it as many as 9 or 10 times. But you have to do it 7 at minimum. So let's look at this one. Here there's something different. It's the same x squared minus 6, but that doesn't look like a positive 9 to me. So instead, what we're going to do is we're going to take this and I'm going to move it. We can either move it away or put it on the other side. So I'm going to add 16 to both sides. I have x squared minus 6x equals 16. And now I've got the space here to put my perfect number to make a perfect square. So having already figured out that it would be negative 6 over 2 is negative 3 squared, that's 9. I'm going to add 9 here. I'm going to add 9 here. So x squared minus 6x plus 9, then this becomes x minus 3 squared, and I have a 25 here. Okay. So to further this, the first thing is we've now completed the square here. The next thing is, in this case, we've got an equation, so we can actually solve this quadratic. So I take the square root of both sides. I'm going to write it out first before I do that. I take the square root here and the square root here, but when you do a square root of a number, you have to remember to do plus or minus. So that means I get x minus 3, because these cancel out, and I get plus or minus 5. Make sure you can see that there. When I add 3, I get two answers, because I have positive 5 plus 3, which is 8, and I have negative 5 plus 3, which is negative 2. Which is correct, because the original problem had an x squared in it, and if you want to get the solutions, that exponent tells you how many solutions you're supposed to have. If this had been x to the 3rd power, you're supposed to have 3 solutions. If it was x to the 7th power, you'd have 7 solutions. We're not going that far, but that's what would happen. In this case, we've got 2 solutions, and if you put 8 in here and worked it out, it would equal 0. If you put negative 2 in here and worked it out, it would be 0 also. So this is one of the ways we end up using the square. Okay, let's look at the next page. And now we're going to see one where we're going to solve the quadratic, but it doesn't come out to a nice 5. That's okay, we can handle that. First thing I'm going to do is I'm going to add the 3 to both sides, like I did on the last problem. And I have x squared minus 8x equals 3. I need the perfect number to go in here, and then I'll put it on both sides, so I need the perfect number to go in here. C is equal to, so look back at those last 2 problems and figure out yourself what this should be. Put the right thing in here and square it, or figure that out and reduce it and square it and figure out what that number is. Take a moment right now to do that. Based on this x squared minus 8x. Okay, now I will finish it. The number that goes on top here is this b. You divide it by 2, so you show that first. Then negative 8 over 2 is a negative 4. Negative 4 squared is a positive 16. So that's the number I'm going to put in these 2 places. X squared minus 8x plus 16 equals 3 plus 16. And this becomes x minus 4 squared. Remember, it's half the number and the same sign. Rewriting it up here because we're running out of space. Now this is where we'll finish it up by taking the square root, plus or minus, and that gives me x minus 4 equals plus or minus square root of 19, and I'm sort of stuck here because square root of 19 is not a perfect square. You're not really stuck, you just have to use it. So when I add 4 here, I'm going to add 4 here, and watch what I get. I get square root of 19 plus 4, negative square root of 19 plus 4. Or you can put 4 plus square root of 19 and 4 minus square root of 19. It doesn't matter. Unless you're going to round it. If you rounded this, you could get, I think it's like about 4.3 or so. So square root of 19 would be about 4.35, something if you made an estimate. So you could do that and do an approximation, but then you'd have to make this approximate. This is an acceptable answer in most cases, depending upon what you're doing. Okay, now, in all of these, we use this number just as it was, negative 8 and negative 6. We'll look at this one, and we have a negative 10. So you think, okay, half of that would be 5, and we'd square it. But you can't, because now there's something different. In this problem now, there's a coefficient in front of the x squared. That changes things. You can only do this method if the x squared has a coefficient of 1. Because if you try it with this right now, it's going to give you a number that won't really work. It doesn't really make a parentheses with a square. So we're going to have to adjust it. So follow along with me. I'm going to rewrite it, but I'm going to add that 17 to the other side. Plus 17 and plus 17. Now when I look at it, I see the fact that this is 2 and that's 10. And 10 is divisible by 2, it would be really pretty easy to take it out as a common factor. That's the key to doing this. I'm going to take a 2 out of both of those. Minus 5x. Left a little space here, so I'll leave it right now. So now when I look at this here, minus 5x, I see that inside the parentheses, I now have a 1 here. Now I can do that normal thing. I can do c equals -5/2 squared. Well, now we've got one of those fractions. It's going to be either -5/2. Well, actually, let's multiply it out here. Okay. I can't really reduce that, but what I can do is square the top and square the bottom, 25/4. In fact, if you prefer decimals, you could write that as, let's see, 4 goes into it 6 times 0.25. So you can either use this or you can use this. This is a decimal that ends, so it's okay to use it. If that had been 25/3, you'd have a repeating decimal, and you can't do that. You'd have to keep it as a fraction. So I'm going to work with it with decimals now because, that seems easier most of the time. 2x squared minus 5x plus 6.25 equals 17 plus 6.25. Notice I did not forget, oops, let's put this up here where you can see better. I did not forget to put it on both sides. But I made a mistake. That's not 6.25. It looks like it, and I'm writing it down, but it's really not. Because everything in here has to be multiplied by that too. Instead of a 6.25, it's really a 12.5. So in the textbook, in the problems where they show this, what they do is they put it here, and they put that number multiplying it by it. So they show that it's this times the 2 that we're putting on both sides, because we're putting this new thing in here. This times 2 is being added on this side, so we have to add that thing times 2 on this side. Now, on this case, we can now make a perfect square, and it was before we square it, it's this thing. So I can either write -5/2, or I can make it a decimal of -2.5. That would be perfectly fine. And that's half of 5 anyway. And then over here, well, 6.25 is 12.5, plus 17 is 29.5. And I'm going to stop here because even though we could solve it by dividing by 2 and taking the square root and adding 2.5, I know those steps, that was not real purpose for it. I wanted you to see about doing that, but I really wanted to get to this point where we can get the perfect square. Okay, let's review this one because this one's more complicated than the others. 2 big things that you need to get out of it. Taking out the 2, and okay to use decimals for this. You can make -2.5 and square that, and when you put it in there, you still do the same thing of just taking half the number to take the square. Oh, and when you add that, you have to add it and multiply it to the multiplier over here. So it's sort of like, here's one step you have to remember, one new thing, and here's another new thing is that you have to include that. And decimals are, if it makes sense there. So make sure you remember that when you have this, because you will have some of them like this. When you do ellipses and hyperbolas in particular, in fact, I can tell you right now you're probably going to have 3 times on the test where you're going to have to take out a common number like this. Okay, so you want to be ready. It might be a 3. If this was 3 and -30, say, then you would have 3 and x squared minus 10x, because you're taking 3 from both of those. Now, sometimes people say to me, wait a minute, we're taking out a common factor. Both of these have an x. Why don't we take out 2x and have x minus 5 left? Mathematically, that's right, but then you can't complete the square because it's not a square inside anymore. So you have to leave the x there so that you have an x squared. Because if you don't have an x squared, then there's no purpose, and you can't actually work it out to get into this format. You have to put it in this format because of the parabola, circle, ellipse, and hyperbola. One of the formats for those requires a parentheses and squared in it. In fact, in ellipse and hyperbola and circle, you do them twice. So let's actually go and do that now. Okay? So these 2 pages, this special lesson, now you see how to do some of that completing of the square, and you'll use that, like I said, a number of times.